This is the second and last section in the series chapter, and in this second section we're going to be looking at the sums of squares and cubes. Now we already know the sum of numbers like 1, so the sum from r equals 1 to n of 1 is n, and also the sum of r from r equals 1 to n, that is half n times by n plus 1. Okay, so these two you are expected to know. They're not in the formula book. We are given formulas, and you don't need to memorize these. These will be in the formula booklet for the sum of squares, the first square numbers up to n, and the sum of the cube numbers. So let's go through these. So if I was looking at the sum of square numbers from 1 to n, it'd be written like r squared. What does this mean? It means 1 squared plus 2 squared plus 3 squared and so on up to n squared, and that's equal to 1/6n times by n plus 1 times by 2n plus 1. Now this can be proved by induction, and when you get to the chapter on that in the book, I believe that is chapter 8, you will be looking at proving these statements from scratch. And the second one for the sum of cubes, the first n cubes. Okay, so that means 1 cubed plus 2 cubed plus 3 cubed and so on up to n cubed. That is 1/4 n squared n plus 1 all squared. So our two statements become this: r equals 1 to n of r squared 1/6n n plus 1 2n plus 1 is number 1, and then the sum of our cube numbers, is 1/4 n squared times by n plus 1 all squared. Yeah, so in the exercises, questions we'll be doing, we'll be using these two, and I'll have them up on the screen as a reminder. Now the rules for putting multiples in the front and splitting statements up still apply. We can use those rules as well. So first example here, evaluate first of all the sum of r squared from 20 to 40. So the first thing that we need to say is, right, if I'm finding from 20 to 40 of r squared, that equals the sum from 1 to 40 of r squared minus the sum from 1 to 19, because I want to start at 20 of r squared. Right, so here we can just use the formulas. So the sum up from 1 to 40 is going to be the first summation sign I've got, is going to be 1/6n. So this n is 40 for the first one, and then it's going to be 40 plus 1 times by 2 times 40 plus 1. Okay, so that's for the first one, and now I want to subtract the same thing but with 19 in there. So it's going to be 1/6 times by 19 times by 19 plus 1 times by 2 times 19 plus 1. So the next bit is just about using the calculator now and being careful to type this in properly. So let's work out the first bracket. So it's 1/6 times by 40, and then brackets 40 plus 1, I know that's 41. Second bracket 2 times 40 plus 1. Okay, so if I work that out, I get 2 to 140. So 22,140, 2 to 140. And then I'll do the same for the second bracket. Now I'm just going to scroll back and change the 340s to 19s. That'll be quicker than typing in it again. So I've done the first two, then 2 times 19 instead of 20. I do that, I get 2470, 2470. So all I need to do now is 22140 minus my answer, and I get 1976, 19,670. Okay, part B. So this time we want to evaluate the cubes from 1 to 25. So I don't need to take off anything. All I need to do is to substitute 25 into the formula a quarter. So n is 25 times by 25 squared, and in brackets 25 plus 1 all squared. That's all we need to do. Plug in the top number into the bracket. So that will give me a quarter. I'm just typing this in. Times by 25 squared, bracket 25 plus 1 is 26, all squared. And I get 105,105, 625. So that's that one. Okay, so that was just a matter of substituting into the formula. Okay, so this one says show that that sum equals that. Right, so the first thing to note is that this sum doesn't start at 1, it starts at n plus 1. Now, our formulas only work when our sum starts from 1. So I'm going to find the sum from 1 to 2n of r squared, but I need to subtract the sum from 1 to n because I want to start from n plus 1. So the value just below n is going to be n, or n plus 1 is going to be n. So that's what I do first. So the next thing that we do is we substitute in n into the formula. So for the first one, it's going to be 1/6 times by 2n, because this goes up to 2n, and then in brackets 2n plus 1 times by 2 times 2n plus 1. So be careful here when you're putting that in. That's the first bit. Minus, now we're just going from 1 to n of r squared, so I didn't write that in, r squared there. So that's going to be 1/6. So this time we're only going up to n. So it's basically the formula. Like this. Right. Now it's tempting just to multiply everything out, go crazy, and refactorize it. But we want to try and be a little bit smart with our working. If we have a look at the question, can you see that there's a 1/6 n out as a factor, and there's a 2n plus 1 as a factor? So we're going to see if we can locate that in both brackets and take them out as factors. Now there's a 1/6 n here and here, which I can take out as a factor. There's a 2n plus 1 here and here, which I can take out as a factor. Now if I do that, that will make the last bit much easier. So look for common factors. Are they what's required in the question? Right. So let's take out the, and actually I suppose my green highlight here should really be highlighting this and this. Yeah, there's my 1/6 n. Right, so let's take out those things as factors. So I can take out 1/6 n and I can take out 2n plus 1 as a factor. Let's see what we have left. So in the first bracket, what I'll have left is 2, and then 2 times 2n plus 1, which is 4n plus 1. So that's what's left after I take out those factors. So that's the first bracket. In the second bracket, I will only be left with n plus 1. Now you'll see that we've pretty much got the answer, and this would be much quicker than trying to expand all the brackets and refactorize it. You'll be there for ages. Right, so in the brackets then, if I expand the brackets here, let's do that, and then we're pretty much almost finished. So 16n, 2n plus 1. In the brackets, we'll multiply that out, so we'll have 8n plus 2 minus n minus 1. So what are we left with in the brackets? Hopefully it's what they want. So 7n, yeah, 8n minus n is 7n. 2 minus 1 is 1. So yeah, it works. Okay, as required. So look for what they want, see if those factors are there and bring them out straight away. It will save you a whole heap of work, because if you sat there and expanded the brackets and then try to look for common factors, it's not easy. So we want to do it the easy way. Part B, verify the result is true for n equals 1 and n equals 2. Right, so if we're going to do this, what we're trying to prove is you get the same answer on both sides for n is 1 and n is 2. So when n is 1, okay, what do we get on the left hand side? Well, the left hand side is going to be r equals 2, because I'm just basically doing 1 plus 1, n plus 1, and then 2 times 1, 2 of r squared. Okay, what's that basically mean? It just means doing 2 squared, which is 4. Okay, on the right hand side, what I'm saying is, right, what happens when I put 1 in? So 6 times 1, and then 2 times 1 plus 1, and then 7 times 1 plus 1. Let's see if we get the same answer. So I get a 6 times by, the first bracket becomes 3, and then the second bracket becomes 8. So that's 1/6 of 24, which is 6. Oh, sorry, 4. Okay, so yeah, when n equals 1, the right hand side, or the left hand side, and the right hand side are equal. Okay, let's try it with n equals 2. So we'll start with the left hand side. So when n is 2, it becomes the sum of r equals, so 2 plus 1, 3, and then, oh sorry, it's not n equals 1, is it? It's n equals 2. So I did put 2 in, but I didn't write 2. And then the top becomes 2 times 2, which is 4 of r squared. Now what does that mean? That means you're going to be adding 3 squared plus 4 squared. So we're going to be doing 9 plus 16, which is 25. Right, so let's check when we do the right hand side, do we still get 25? By putting n equals 2. So it's going to be a 6 times by 2 times by 2 times 2, there's my n plus 1, times by 7 times 2 plus 1. So if I work that out, so 6 times 2, that's 2 over 6, that's a third. Then in the first bracket, I'll get 5. Then in the second bracket, I'll get 14, 15. Okay, so what do I get? I get a third of 75, a third times 75, which is 25. So the right hand side equals the left hand side when n is 2. So we've proved the statement is true for n is 1 and n equals 2. And when you get onto proof by induction, you're going to find that this forms like one of our first steps of the proof. Show that statement equals the other statement. Right, so first thing that we're going to do, we start from 1, which is nice. This r squared plus r minus 2, we're going to split up into r squared from 1 to n, r from 1 to n, and then minus 2 lots of 1s from r equals 1 to n. Yeah. And then we can put the formulae in for this. So r squared becomes 16n, n plus 1, 2n plus 1, plus, this is the one we need to remember, half n times by n plus 1, and then minus 2 lots of n. Now if we look at what we need to get, can you see there's a third n outside the brackets, and I don't see a third n in any of the brackets. I could play around with the algebra to get a third n and then try and take the n plus 4 out, but this one might be easier just by multiplying everything out. Now I'm actually going to leave the 1/6 outside. I'm not going to multiply that because I think that will make things a little bit messy. So I'll keep the 1/6n here, but I will multiply the double brackets I've got there. So that's going to be 2n squared plus 2n plus n plus 3n plus 1. Okay, so that's the first square bracket there. Then for the second bracket, yeah, I'll multiply that all out. Now I'm going to keep the half here, and then I'll get n squared, so half n squared plus half n. Okay, so I'll leave it like that, and then minus this 2n at the end. Right, let's see what we can do to try and tidy this up. Now I'm actually going to take out a third n as a factor of each bracket, and I'll show you how I can do that. So if I took out a third n, what that means is to make this all balance, I need to put a half here, yeah, and then I'll have 2n squared plus 3n plus 1, yeah. In the second bracket, if I took out a half or a third n, that would leave me actually with 3/2, because 3/2 times a third will give me a half. There are other ways of doing it, but this is the way I would do it. So then I get that 3/2n, and then plus just 3/2. So I'm basically forcing a third n to be a factor. And then with the last bit, if I took a third n out as a factor, then what that would leave in the brackets would be 6. Yeah, because 6 times a third would be 2. So let's take that factor and stick it right at the front now. 1/3 n, it's a factor of everything. So in the brackets, I would have a half of all of this stuff. So let's do that. So n squared plus 3/2n plus a half. From the second bracket, I would have 3/2n plus 3/2. And then from the last bracket, I would have minus 6. So just check to see that you understand what I've done there. Yeah, so this basically comes from the first bracket here. This came from the second bracket here, and this came from the third bracket here, because I've taken that third n out as a factor. So putting together the bits in the brackets, I have a third n out, still outside. Then I've got just n squared. Then I can see that I've got 3 over 2n plus 3 over 2n, which is 6 over 2n, which is 3n. Then as far as numbers are concerned, I've got a half, add 3 over 2, which is 4 over 2, 4. Sorry, 2, it's 4 over 2, which is 2, and 2 take away 6 is going to mean minus 4. Right, this bit in the brackets can be factorised with n at the beginning of both brackets. And I want two numbers that add to give me 3 and multiply to give me negative 4. So that's going to be plus 4 and minus 1. Minus 1, and we've proved it as required. Now, there are lots of different ways you can factorise that. You can multiply out completely. You could take a factor out right from the very start. It is totally up to you. Do what you feel comfortable with on these questions, what works for you. And part B, hence find the sum of 4, 8, 18, 28, 48 up to 418. So let's write that out. Okay, so at first this may look totally random, but let's have a look at what we get. Now, if I put r equals 1 into this up here, so let's just highlight this. So if I put r equals 1 into this, what number do I get? So I get 1 squared, 1 plus 1 minus 2, I get 0. So when r equals 1, what I get is 0. Okay, what do I get when r equals 2? So when r equals 2, I get 2 squared, 4, 4 plus 2, 4, minus 2, sorry, that's 4 squared plus 2, sorry, 2 squared plus 4 plus 2 minus 2, which is 4. Okay, when r is 3, what do I get? So I get 9 plus 3, which is 12, and I get 10. It looks like I'm getting these numbers in a sequence, isn't it? When r equals 4, what do I get? So I get 16 plus 4, which is 20, 20 minus 2. Well, okay, I'm getting a sequence. What I really need to do is to work out, well, what value of r is going to give me 418. So I can work out, well, what's n? How far am I going? So in other words, r squared plus r minus 2 needs to equal 418. So I can work out, well, how far am I going in this sequence? What value of r am I going up to? Okay, so r squared plus r equals, well, actually it's a quadratic, isn't it? So if I take away 418 from both sides, I will get r squared plus r minus 420 equals 0. Okay, now I'm going to solve this. I'm just going to use my calculator to solve it. So I'm going to go to A from the menu. I'm solving a polynomial of degree 2 where I've got 1 in front of x squared, I've got 1x, and then I've got negative 1 to 420, and I get x is 20 or x is negative 21. So r is either 20 or r is negative 21. No, it can't be the negative 21. Yeah, so it has to be 20. So what I'm going to do over here is I'm going to use the formula with n equals 20. So I'm just going to say let n equal 20. So I'll work out a third times 20, and in brackets 20 plus 4, 20 minus 1, and that should give us the answer. So that's 1/3 times by 20 times by 24 basically, and then times by 19, and I get 3014. So that's my final answer. Now, not just in this, but any question where you see this word hence. Hence means it will be so much easier if you used what you have just worked out or shown in the previous part of the question. That's the easy way. Yeah. The hard way is let's work out from scratch. So hence means use what you have worked out previously to help you. It's giving you a clue. Okay, this example here show that that sum equals that, where a and b are integers to be found. So we're going to work out what those numbers are, and then we've got a calculation to do. Okay, so first of all, well, this is going to need multiplying out. Because we want to find if there's any squares or cubes or anything like that. Right, so r equals 1 to n. So I'm going to multiply out the brackets like this, and then I'll multiply by r. I'm not going to do it in too many steps, so I'm going to try and do this nice and quick. So the first term is going to be 2r squared, but then it's going to get multiplied by r. Everything's going to get multiplied by r. So, actually, let me write out the full steps. So here, r times by 2r squared. Then I'm going to have minus r plus 6r minus 3. Okay, now let's tidy that up from 1 to n. So that will become 2r cubed. Now we've got negative r plus 6r, which is going to be 5r, times by r is going to be 5r squared, and then minus 3r. Right, next step is now to split that up. So it becomes 2 lots of r cubed plus 5 lots of r squared minus 3 lots of r. Next step now is to put the formula in. So 2 lots of r cubed, that's a quarter, n squared, n plus 1 all squared, plus 5 lots of the squares, so that's 1, 6, n plus 1, 2n plus 1, minus 3 lots of half n, n plus 1. Right, so like before, can we see any common factors? Because this is going to be hard work to multiply this all out. Well, straight away, I see n plus 1 there, so I can take that out because that's what I want as a factor. There's an n plus 1 there, there's an n plus 1 there, so I'm going to take those out. Now in terms of a 6th n, I'm going to do what I did before, which is try and get maybe a 6th n on these. Now that may not be Oh right, I've just realised I missed out an n here because I was looking at it thinking, oh, that's going to be hard. So it's actually meant to be an n there. I missed that out. Now, we might be able to do that. Let's take out the n plus 1 first. See where we go. Right, so n plus 1 out as a factor. So first bracket will leave me with, now if I'm doing 2 times a quarter, that's going to be a half. So let's do a half n squared, but I'm still left with n plus 1 because I've only taken those one of those n plus 1s out as a factor. Second bracket, right, so plus 5. I'm taking the n plus 1 out as a bracket, so there should be like big brackets around this whole thing here. So 5 and then times by 6n. And then I'm just left with 2n plus 1. Then in the final bracket, that will just be minus 3 times a half n. I could do 3 over 2. And I've taken out the other n plus 1 as a factor. So I've got something like this. Right, and what I'm going to do now, I want to write it in a form where I can take out a 1/6n. So I'm now going to take out 1/6n. Now I can do it here easily, but what I'm going to do is I'm going to rewrite this and I'm going to rewrite this in a slightly different way to allow me to take a 6 out, because a half is 3 times a 6. So I'll need to put a 3 somewhere else. Yeah, a half is 3 times the 6. So I need to put a 3 somewhere else to make it all balance. Right, so 1/6n. Right, so what are we going to get in the first bracket? Well, if I'm going to take a 6 out, but a half was there already, then to make this all work, I need to put 3n. Now it was half n squared, so to get half, for that to work, I just need to put 3n. Okay, then I've got, that's times by n plus 1. Right, that's the first bracket. The second bracket, right, plus, now that 1/6n goes straight out, just leaving me with 5, and in brackets 2n plus 1. Now the last bracket, if I'm going to take a half n out, I need to put, sorry, if I'm going to take a 6n out, I need to put a 3 in there somewhere to make that all work. So I'll end up with -9. Yeah, so let me just make that a little bit clearer. So 3 times a half, I'm taking a 6 out, a 6n, so that n's going to go out the front along with that's 1/6, but I had a half here, so to make it all balanced, this needs to be 3, and then I've got 3 times 3, which is 9. So hopefully we're almost there in terms of finishing this off. So it's going to be multiplying out what's in the brackets. So 3n squared plus 3n plus 10n plus 5 minus 9. Oh, I missed out because I'd already taken the n plus 1 out as a factor, so that should have been there as well. Yeah, let me put that in. Sorry about that. So I've just taken a 6n out. I already took out n plus 1. So I'm going to put that there as well. Now I'll put down what's left inside our bracket. So I'll multiply it out, multiply those. So 3n squared plus 3n plus 10n plus 5 minus 9. So that gives me 1/6n, n plus 1, 3n squared plus 13n minus 4. Right, now hopefully that should factorize. Let's see. Oh no, it's done. It's in the right form. I thought we needed to factorize any further. Right, so in that case, we have A is 13, B is negative 4. So there's our answer for part A. Now, as I said, there's lots of different ways of factorising it. I have just chosen one way. You can do it completely differently, whatever works for you. Part B. Hence calculate. Right, that sum. So that sum from 11 to 40 on r plus 3 to r minus 1 is going to be the sum from 1 to 40 of this r plus 3 to r minus 1. Subtract the sum from 1 to, so if I'm going from 11 up to 10, r plus 3 to r minus 1. Right, well, so what will that equal? Right, so we need to stick 40 into the formula. So it's going to be 16 times by 40 times by 40 plus 1, 41, times by 3 times 40 squared plus 13 times 40 minus 4, and then we need to subtract the same thing, but now we put 10 in there, so 16 times by 10 times by 11, that's the n minus 1, n plus 1, times by 3 times 10 squared minus 13 times 10 minus 4. Right, let's work that all out on our calculator and see what we get. So after typing that in from the first bracket, I get 145. So 1,453,040. Now I'm just going to scroll back and change the 40s to 10s. So 10, the 41 I'll change to 11. The 40 squared becomes 10 squared. The 13 times 40 becomes 13 times 10. Now I can press equals and get 7,810. Well, I'll put the answer over here because I've got a great deal of space. So that's my first answer, 1453040 minus my answer. And I get 1445230. Okay, so that's my answer for part B. So let me just tidy this up and highlight it because there's a lot of work in here. So there's part A, and here's the answer to part B. Okay, you should now be able to do exercise 3B on pages 49 to 51. So remember, those formulae are given in the formula book. Remember your sums of your r's, which is half n plus 1, and your sum of 1's, which is just going to be n. So you do need to know those two. The other two are given. And when you've got these questions, rather than just multiply everything out, when you've got one of these proof questions, look for factors and bring those out of the front straight away. Or is it possible to make something a factor quite easily and bring that out to the front? That will save you a lot of time rather than just multiplying everything out and then looking for a factor. That's quite tricky to do. So look for factors first, then you're left with something much easier and simplify at the end.